more thing. Okay, I think we are finally set up here. Sorry, I came in yesterday afternoon and thought everything was okay, but I didn't think to check that, so that was the hassle. Okay, so there was a handout you guys picked up this morning. It is number 92. So last time I saw you, if you were absent last time, we were in a different classroom. We did the first half of this unit test, which was 50 points over 1.9 inverse functions, 3.1 exponential functions, and the start of logarithms 3.2. So if you missed that, you need to try to come in during advisory before the week's out to get that caught up, please. But now we are moving on and finishing up the other half of this unit. So we've got another 50 points assigned to 3.3 and 3.4, and 3.3 and 3.4 is strictly logarithm stuff. 3.3 is, we're going to talk about something called expanding and condensing, and usually you guys see this in Algebra 2, but all my classes yesterday, no one recognized it, so you guys may not have gotten to see it from Algebra 2, and that's okay. It's actually not too bad. It would just be a little bit more unfamiliar. And then when we get to section 3.4, we'll solve some more equations, some more complicated ones than we made you do in section 3.2. So there's also a big book assignment here, which is why I asked you guys to go ahead and start on it. Really, the first 10 are mostly about change of base. The second 10 are about evaluating without a calculator, which we've also done, just need to be better at. And then the last 10 will be about expanding and condensing, which is what our notes are over. So let's go ahead and look at the notes, and then that way you guys can move on to the book assignment and hopefully get that done before you leave. Okay, so to expand or condense logarithms, there's really only two ways to condense, and if you really understand those two directions, then expanding is the exact opposite. So you're just undoing that. Bless you. So to condense logarithms, what it means is you take two logarithms of the same type, log base 3, and you push them together into a single log base 3. Now the only two ways to condense is if they were separated by subtraction, they're going to condense with division. 5 comes first, so it's the numerator. 2 comes second, so it's the denominator. And if they're separated with subtraction, you condense with multiplication. Subtraction condenses to division. Addition condenses to multiplication. Now, on this one, we know what 5 times 2 is, so we need to go ahead and change that to 10. So if you were to look this up in the textbook, it's going to just use generic numbers here, but they have to be log of the same type, same base. When you condense them, they're going to be the log of that type of base. And if it was subtract, then you divide. If it was add, you would multiply. Now we're basically going to undo this with expanding, but you need to be careful. Division never condenses, multiplication never condenses. If you're wanting to condense, subtraction becomes division, addition becomes multiplication. But don't try to oversimplify and just think, well, subtraction and division switch places and addition and multiplication switch places, because that's not true. So even though this is not really relevant until section 3.4, I want to give you one quick example of, there's a handful of reasons why you want to be able to condense beyond just class grade and ACT. But if I ask you to solve something like this, this would not have been fair game on our last test because you would be stuck pretty early. But after we practice expanding and condensing, you can condense these two into log base 3 of 10x. I'm multiplying those because they were separated with addition. And it still takes some more work, but it at least puts it in a way that we can finish it with stuff we've done before. So we've talked about switching it from logarithmic form to exponential form. Yep, thank you. Logarithmic form to exponential form. Divide both sides by 10. But if you don't know that it's possible to condense, or you don't know how to condense, you're going to be stuck at this first step the whole time. You're going to be looking at that equation forever. But what I underlined in red and wrote in red allows us to fall back on previous stuff that we knew. Again, that's not too important right now. I just wanted to show you one quick example of where you would maybe want to condense. Okay, if you really practice that and make sure that you really understand the condensing part, expanding is just undoing that. So I don't feel like this is anything different. We're just going the other direction. If they have a division and I want to split them apart, I want to expand them. The 4 should go first because it's in the numerator. The 3 should come next because it's in the denominator. And if this is division, it must have been expanding subtraction. Let's go in the exact opposite of questions 1 and 2. Now again, just out of habit, if something simplifies nicely like this is just 1, we should just go ahead and change that. And if they were condensed with multiplication, then we can uncondense them, known as expanding with addition. And since that one comes out to 2, we should go ahead and change that. So there's only 2 ways to expand, only 2 ways to condense. So I'm going to try to help you hopefully not fall down a very common trap here. If you are condensing, subtraction becomes division, addition becomes multiplication. If you're expanding, division becomes subtraction, multiplication becomes addition. But that's it. If you try to go outside of any of those things, it does not work. If this was divide or multiply, you cannot condense divide or multiply. If this was subtract or add, you cannot expand, subtract, or add. So you can't simply in your head say, well, subtraction becomes division and vice versa, and addition becomes multiplication and vice versa. No, don't do that. Subtraction becomes division, addition becomes multiplication, and then you can undo those if you're going the other direction. But if this had been division, you could not do this. If this had been multiplication, you could not do that. Only subtraction and addition condense, only division and multiplication expand. Okay, and then one quick example of maybe why you would want to expand. So this type of question would have been fair game on your last test. I honestly don't remember if there was one, but you would have been kind of limited on how to work this. The only thing you could have done is to use exponent rules, and there's nothing wrong with that. But 7 to the negative 4 in the denominator is the same thing as 7 to the positive 4 in the numerator. And then because this 4 is an exponent on something we're taking the log of, the 4 can come down out front. Log base 7 of 7 is 1, so your answer comes from 4 times 1. So that's still fine. You're still welcome to do it that way all the time if you want to. But now that we know about expanding, I want to show you that you have an option. You could expand this to say log base 7 of 1 minus log base 7 of 7 to the negative 4th. And for some people, they're going to think that this is easier. This is 0 because 7 to the 0 gives you 1. This you could bring down out front. Log base 7 of 7 is 1, and you still get 4. So I'm not saying that you have to do it with expanding all the time now, and I'm not even saying it's easier. I'm just showing you that it's just a different method to achieve the same thing sometimes. So if you ever think that that would work, if you ever think it would be easier, if you ever had one like this that you wanted to check your answer on, that would be a good way to work it a second way. Bless you. Okay, so on the back page, So a couple things to just kind of clean up before we can actually practice this, because again, that's it. There's two ways to expand, two ways to condense, and you just got to practice it a few times to make sure that you know what your answers need to look like. So when we condense, you need to know that all of the coefficients need to be brought up as exponents. And what I mean by that is if I asked you to condense these, you might see that they're both log base 5, or 3, sorry. So you would condense to a log base 3. Because they're separated with subtraction, means you would condense them with division. You might think that this is 5 and this is 2. The problem with this is you're completely ignoring this 2 out front, and you can't do that. You can't just pretend like that's there, not there, and or just hope that you put it in the right spot. You really need to bring this up as an exponent before you can condense. So when you're condensing, if there's a coefficient out front, coefficient just means the number that's being multiplied by something. If you have a coefficient on your log, bring it up as an exponent to get it out of the way. And then you can condense like normal. But if we're going the other direction and expanding, at the end of the questions we want to do the opposite thing. I don't know why this is the standard, but it just is. But when we expand, at the end, if there's any exponents, we need to make sure that we bring them down as coefficients. So if I ask you to expand number 10, they're separated with multiplication. So you could do log base 3 of 9 plus log base 3 of x squared. This simplifies to be 2. And over here, you might not think that you can do much with this, but again, if the directions say expand, there's an expectation that you bring all of your exponents down at the end. Again, mathematically, they're equal, so I don't know why that's such a big deal, but everyone just does that. So. Okay, so to help you maybe see what kind of traps you might fall into, I'd like you to try 2 of these real quick, just one condensing and one expanding. I will warn you that number 12 is a little bit trickier, but it's good for you to see if you fall into that trap without a warning. So try those real quick, see what you come up with. Then we need to review some exponent rules and change a base. Okay, so 11, let's check that one. 11 I think should have been just a little bit easier since I just warned you about what to do. If you're condensing and you have a coefficient, you really should bring that coefficient up out of the way. It will make your life easier. So both of these were natural logs. So when you condense, they'll be natural logs. They were separated with subtraction. They're going to condense into division. The first one makes up your numerator, and the second part makes up your denominator. Try not to do any more than that. Okay, to expand, if we start off with natural log, when we expand these, they're going to be natural logs. And division expands into subtraction. But the first tricky thing about this question is, just because I expanded this step correctly, it expands more. Over here, these two are being multiplied, so we can expand these into a natural log of y squared plus a natural log of z cubed. Also, kind of minor, but I don't know why, but it is understood that when you expand, all of your exponents need to come down at the end. Excuse me. But what I have written down here is not correct. And it's something that's very easy to look over. And this used to be kind of the classic ACT type question where they would test you on this. So, any suggestions on what I did not do? Right, this is minus all of this. So when you expand it, it's still minus all of that. It's not just all of a sudden minus the first part and not minus the second part. So you either have to have parentheses or you need to make this last sign a minus. You have to distribute it. One or the other. I will say that one nice thing about these question types, especially like on tests and stuff if you have time, if you're willing to take a moment and condense this, if it doesn't condense back to what you started with, then it can't be correct. So you can always work your answer backwards to make sure you go back to the question. If you didn't have those parentheses, your z cubed would be in the numerator, not the denominator. So go ahead and update that, make corrections if you need to. And then we need to remind you about change of base. So this comes up in this section again, although we needed to know that for the test anyway. So change of base with the common log. Change of base with the natural log. So I'm not saying anything new there. Hopefully you know that already. And then for question 14, a common thing that comes up in these question types is you need to remember how radicals work as exponents. So a square root can be thought of as an exponent of a half. A cube root is like an exponent of a third. A fourth root is like an exponent of a fourth, etc. And we need to use that quite a bit in these question types. For example, if you were asked to expand this, you would do log base 5 of 7 plus log base 5 of square root of x, because multiplication expands as addition. But because in expanding you're supposed to bring down your exponents, the answer is going to look like this. Because you can think of square root as an exponent of a half, and because that's an exponent and you're expanding, you should bring it down before you circle your answer. So if we check an answer to something and there's a half in there and you don't know where it came from, it's probably that they dealt with the square root. There's a third somewhere, it's probably because there was a cube root somewhere. Okay, let me put the, or is there any part of the notes you need me to go back over, or any questions that you know that you have? Okay, let me put the assignment back up then. So I read off to you the first 10 questions, but go ahead and copy down the other 20. And most of these questions are super quick, so 30 questions sounds like a lot, but in my classes yesterday, people were finishing this in class, so it just kind of depends on how long you need. But roughly the first 10 are about change of base. The second 10 are mostly about evaluating logs without a calculator, more practice with that. And then the last 10 get more into the expanding and condensing. So let me give you about, let's say 10 minutes. I think 10 minutes is overkill, but in 10 minutes you need to have tried the first 10 questions and know which ones you'd like to ask and double check with me. Obviously you should check the odd ones in the back of the book, and the even ones you can ask me real quick and I can share with you. Then I give you another chunk of time for the next 10, and then finally I will answer some of your questions from the end as well. But we need to hustle along here to want to do that without having homework. Go ahead and keep on going. Get as much done as you can, but another 2 minutes, and you need to know which questions from the first 10. So that would be 1 through 24. Okay, so if you don't have questions, go ahead and keep going. But from 1 through 24, which ones do you want me to check with you?
Go through 21.
21? First thing I would do in 21 is change this cube root into an exponent. Cube root is the same as an exponent of a third. And then since this is now an exponent on something that you're taking the log of, this can come down out front. And 6 to the first would give me 6. So if I want 1 over 6, I want this to be -1. 6 to the -1 is like 1 over 6 to the +1. So that's where you should end up with -1/3. You okay with that?
Yeah.
Okay. Sorry, Julia, what? 22? I think it's got similar pattern to 21, but instead of a cube root, it's a 4th root. But I would still start off by changing that to an exponent. Seeing that it's an exponent on something I'm taking the log of, so it can come down out front. And then what is log base 2 of 8? So it looks like our answer is 3 times a 4th or 3/4. Most of the time though, cube roots, 4th roots, you want to change them to exponents before, as a way to deal with them. Okay, what did I say, 1 through 24? Okay, others 1 through 24? Yep.
24.
Number 24? Alright, that one's going to be quick. So this is asking you 3 to what power gives you -27, which should give you some problems. But remember, you can't take the log of 0, and you can't take the log of negative numbers. The reason why you can't do that in your head is because it doesn't work. There's no number that makes that true. So just like when we were checking equations and we were plugging them in to make sure that our answers were not extraneous, same thing here. Question 23 and 24 are both not possible because you can't take the log of a negative number. And that's all you had to do. Others 1 through 24?
What's number 2?
Number what?
Number 2, what's on
If you want to change this with change of base with base E, when they say base E, they're meaning use change of base with the natural logs. And so that would be like this. That's the change of base, the version of the change of base that has base E's. Okay, any others? First 10? Okay, I think 8 of the next 10 are still evaluating, like question 21 was, the first one y'all asked. And I think at the end, two of those do some basic expanding, but I reset the timer here. So in another 10 minutes, I would like you to have the questions ready that you need from the second group of 10. So that should be 25 through 43. But obviously keep going if you have time. as always, you should be checking the odd ones in the back of the book. And the even ones, if you're not sure about, you can feel free to ask. You got about 4 more minutes.
You can't do, what you're doing with that square root doesn't work. You can either rewrite this fraction when you started with, instead of being to the 1/2 in the denominator, you can make it to the negative 1/2 in the numerator. Or you could expand this and then work the two parts separately, whatever you think is easier. But the way you were dealing with that square root in your second or third step is not. And then work those two parts separately.
Wait, is that just got a L and E7?
Okay, yeah, because these are gonna cancel, and these are gonna cancel your address letters.
Okay.
Or about this way, pretty easy for that. Those 5 steps.
Okay. I'm doing it tomorrow. Bro, I finished my essay tonight and studying for that test. It's not a good test. I've got like the intro and then that was my first paragraph. All of that's fourth done. But
And the student
huh?
the student line.
Nice. I'm gonna study how to study it today. Story. I kinda like her though. Most people don't.
He's just so simple. She looks like 40. He wasn't a person.
I can see that. Kinda.
On the right side.
We have to finish the rough draft. That's class
I would say, who do you got?
Oh.
I've heard Miss Edmonds the best.
Yeah.
I wish I got it.
We don't have to do it pretty good, so.
Well, I'm maybe 80, which I'm actually, as a, no, just clutch.
She didn't want to read it.
No, I guess not.
Did you number all your, you have to number all yours?
No, well, you don't have to number them, but just, I just counted them, like beforehand, it's like,
She didn't write down,
so,
so.
when you get to 80, that's really the next grade that takes over. I wasn't gonna do before. is what? Really? Honestly, $20 is a really good deal.
That's true.
'Cause that's like, it's smart. It's like, I'm already too far in. So, I was like, for like $20, that's crazy. It's basically like 5+ hours of work. Yeah, but still. Nice. That'd be funny if you got caught with that. But I doubt it. Plus I doubt that he would even think of it. The odds of you getting caught are probably like less than 5%.
Sorry about that. So, let's see, your second set of 10 would have been 25 through 43. So, the first handful of those were on evaluating still, but that doesn't mean that they're easy. Obviously, we wouldn't ask you to practice more of them if we didn't think that there was still some practice that you needed. But from those, what did I say? 25 through 43, which ones would you like me to help you out with or tell you the answer to if it's even? And you can check in the back of the book. Yeah. 28. Let's see, 28, we've got 2 times the natural log of e to the 6th minus the natural log of e to the 5th. So first thing I would do is go ahead and bring these exponents down. So bring this 6 down, multiply it by a 2 that was already there. Bring the 5 down, multiply it by the 1 that was already there. And then natural log of e is 1. That's one of the more important ones to know, because this is saying e to what power gives you e. So this is 12 times 1, this is 5 times 1, so in the end you should end up with 7. Okay, others from that group? I thought y'all would have more than that, but
Negative 26.
26. Okay, now I'm going to do 26 quickly because I'm going to show you 2 different ways. The way that you would have had to have done this on the last test if we had done this is to make this exponent of a half, move it to the numerator, which would make it a negative exponent. Then you could bring it down and multiply it by the natural log of e. So that's how you could do it with exponent rules. And or, now the new thing, expanding, you could expand this as natural log of 1 minus the natural log of the square root of e. And then this becomes 0. This exponent can come down. Natural log of e is 1. And you get negative 1/2 that way too. So you've got options now. Is that okay? Okay, what was the other one, Bo? Was that you?
32.
32. Okay, 31 and 32 we did like one of these in 3.2, but not very many. So these are the ones where I know it's possible to do without a calculator because it says it in the directions. And if I try to think of nice whole numbers, my answer has to be bigger than 1 because 8 to the first is only 8. It has to be less than 2 because 8 squared is 64 and I only want 16. So I know my answer is somewhere between 1 and 2, and that's important because it tells me my answer is a fraction. So these are the ones that I said you might want to do in 2 steps. Raise 8 to a power to make it something else, and then raise that to some power to get it to 16. So I would start off by raising this to the 1/3 because that's like cube root, and the cube root of 8 comes out to a nice even 2. And then now that I've lowered this base, 2 to the 4th will get it to 16. So if I want to raise it to the 3rd and to the 4th, if I want to do both at the same time, you need to raise it to the 4/3. So you don't, if you can do it in 1 step, that's great, but for most people it's a lot easier if you do it in 2 steps. Do square root or cube root or 4th root with the fraction, lower the base to a nice even number, and then it should be, the second part should be a lot easier to figure out in your head. But then to do both, you got to multiply them. Okay, somebody else in that second set of 10? Or the first set of 10 if I moved on too quickly from those earlier? Okay, this time I'm only going to do 5-minute timer and ask you to get at least the next 5 done. So that would be 59 through 66, because this is where it really starts to dive into expanding and condensing. And if you're making a mistake, I want to help you catch that sooner so that you don't have to redo a bunch of questions. So, next 5 minutes, you need to be ready to tell me which questions you have from the next 5. I realized that a lot of those were even, so I went ahead and wrote out what I would have as answers on those 5. So 59 was an expanding question. You can choose to distribute that 1/4 if you want to. And then 60, same thing. 59 and 60 are pretty much the same steps, same level of difficulty. Oh. So if you need me to work out one of those, I can. Then 62 wanted you to condense, but that was a pretty easy one because it was just very straightforward. 64 almost seems like there's nothing to do, except that when you condense, you should always bring up the exponents to get them out of the way. So that's really all that could be done in 64. And then the 5th one, you needed to bring up the exponents and then condense addition into multiplication. So, of these 5, which would you like me to go over step by step? Yeah. 59. Okay, so the first thing that I did is I thought of this 4th root as an exponent of a 3rd. A 4th, I mean. I brought it down, got it out of the way. And then since this question said to expand, multiplication is going to expand into addition. And it was 1/4 times all of that. And then because of the direction we were going, there's an expectation that you bring the exponents down at the end. So that's where I got that for 59. Now, as we get on to these last questions, similar to this one, questions look more complicated, your answers are going to look more complicated, but it's going to be the exact same stuff. Dealing with roots as exponents, bringing exponents down, multiplication, expanding as addition, division, expanding as subtraction, or vice versa, and bringing the exponents down if you're expanding at the end. So as we move into these last ones, you'll see that you're going to be doing the same thing, I'm going to be saying the same thing, but the questions will look harder and the answers will look more complicated, but still working out the same. Okay, any of these other 5? Okay, so then that should put us at, I think, 5 more. So go ahead and try the last 5. Since those are even, I will work them out and leave the answers on the board. That way you know which ones you need to ask about. And I will work as many of them as we have time for. But if we do run out of time, we still got about 9 minutes. If we do run out of time, I do have all of these worked out as videos, short of a couple of the first few questions that we've already gone over. So if you do need any help with the last couple, just make that your homework, since I don't have anything else for you for homework. As you finish those 5, compare with what I have and make sure yours is equivalent. And I give you a couple more minutes and then I'll try to squeeze in a question. So try to narrow it down the best you can. Okay, is there one of those that you felt was harder that you'd like me to discuss real quick? Yeah. Number 70. Log base 3 of x plus 1/4 log base 3 of y minus 4 log base 3 of z. So this was what I was meaning by the questions are going to look more complicated, but we still need to just focus on the same 3 or 4 things that we're doing in all the questions, such as bring the exponents up to get them out of the way. This is a y. You need the exponents up out of the way before you try to condense. Addition is going to condense into multiplication. Instead of saying this is y to the 1/4, you can leave it that way, but I just wrote it as the 4th root of y, same thing. And then subtraction condenses into division. So this stuff would make up your numerator. That stuff makes up your denominator. That's where I got that as an answer. So dealing with the exponents the same way in step 1. Condensing addition with multiplication, and then condensing subtraction with division. Doesn't matter that the question's longer, looks more complicated, it's still applying the same properties. Okay, did you get what you needed from that? Okay. Yep. So if you did not finish 74, sure. Just make sure that you guys finish. For homework, please, you shouldn't have but just a couple. And I will see you again tomorrow since this is a B week. Okay, in 74, first thing I did was just get rid of this 2 by distributing. Since I'm condensing, I need these coefficients up out of the way, so I brought them up as exponents. Then I went ahead and condensed these 2. Subtraction condenses to division. Carry this part down for a second. And then I condensed these 2, and once again subtraction condenses to division. But when you divide a fraction by a number, it makes your denominator bigger. So this goes in the denominator. And that's how I came up with that. And if you have trouble seeing why this went to the denominator, you might think of it as if you're dividing by this, it's the same as multiplying by its reciprocal. And if you're multiplying by 1 over this, this stuff gets put in the denominator. switch it back to the agenda. So, to be honest, those last few questions, those are like super extreme, expanding and condensing. Realistically, you don't ever really need to expand or condense any questions quite that complex. But if you can do those, then you can certainly do the ones that you need to be able to do. But tomorrow, we will start looking at some of the other equation types to solve, and we spend a little bit longer on that because that takes more practice. But some of this stuff will carry over into that. So make sure you have this finished. If you need help with any of the last ones, use the videos online. And I guess that's it. If you did not take your test, please try to come in today during advisory. If you didn't do today, you need to make sure you do tomorrow.